Welcome in this next video, part of the iOS application attack service. If you're watching from YouTube, make sure to also subscribe to the course on Mobile Hacking Lab so you can get access to the workbooks and other features. Now let's talk about device and OS level features. So first we will start with keychain security. The keychain we already covered in the local data storage section, so please also follow that section if you want to do some exercises with the keychain security and storing data in the keychain. So if you go to the mobile application security testing guide from OWASP again, then there is also an explanation about the keychain. So you can use the keychain API as a developer, and then you have different operations for create, update, delete, and also one for copy matching. And what you can do as first check, you can verify if one of those options is used within an app. So I can show you this in a few seconds on a VM. So in this case, I've extracted the threads application, and then the IPA file you can just extract as a zip file. Then you have a payload and this app directory, and then there is a binary called threads. And if we just do a grab on sec item in this binary, then you can see the update, the add, copy matching, and delete are all used. So this app is for sure using the keychain. So this is just one of the basic checks. And a second important thing about the keychain is that it has different accessibility types. I think the first one, accessible always, is even deprecated. So then that data is always accessible, even if the device is locked. And all the other options are only accessible if the device is unlocked and it's limited to a device or not limited to a device. And as a developer, you should follow the documentation of Apple and the latest best practices. So then you will already notice that whether the device is locked, that those two options are deprecated. But as I said, we already covered the keychain before. So I would like to go a little bit deeper into the second and the third topic, which are also related. So weak implementation of Touch ID or Face ID. There is also a specific API for this, which is called the local authentication framework within Apple. And then there is the local authentication context, which is the class you will use. And then, for example, this evaluate policy is then a function which can return true or false. And this is already a potential issue. And then we have the local authentication framework, which is also related to the keychain and also Touch ID and Face ID. So they have two options. Local authentication framework is a high-level API that can be used to authenticate the user via Touch ID. And there's also a security framework. And this is also important information. It utilizes the function evaluate policy and the LA context, local authentication context class. Then we have this context class also in the documentation. And you might already notice can evaluate policy returns a boolean, and also evaluate policy also returns a boolean. So let's look into an example. If you're not using a physical device with a Corellium device, then you should configure one thing before you do this challenge. You should go to sensors, then biometrics, and then you should disable this biometrics bypass, because we want to do this ourselves, not using this feature. And then we can open the damn vulnerable application. And then there is a challenge called Touch Face ID bypass. So we can do start challenge. Then there is a Swift implementation and an Objective-C implementation. Now it will not prompt for a fingerprint in this case, because I don't have a physical device. But still we can use this, because we do get feedback that the authentication has failed. In this case, I'm already have an iOS device available over USB. So I'm connected over VPN so that I'm in the same network, and I'm using USB Flux to set up the USB connection. But this is already covered in the pen testing basics. So if you need a similar setup, please also check that section. So let's start with Frida PS -U from USB and then A from all active processes. And first I want to use Frida trace, also USB, and then -M, which can be used for Objective-C and Swift methods. And then the signature of the method always looks like this. So the first star means the return value. So plus for Boolean, for example. Then we have the package name. Then we have the class name. And then we have the function name. So in this case, I only know one value, which is LA context. And then we have to attach it to the process 832. So let's try this. Tracing 171 functions. Now I want to verify if something happens. If I click on one of those, Swift implementation, authentication failed. And then we get a nice output, LA context in it. And it also does something with can evaluate policy. So then we know this local authentication framework is used with these specific functions. And we can also try the other one, the Objective-C implementation. And then it looks quite similar, I must say. So now you can bypass it, creating your own FRIDA script to set those policies, or you can also use objection. So I will show you a FRIDA script, which is the more difficult way. And then in the workbook, you can also try this with objection. So now I'm going to stop FRIDA trace. And I already prepared a script. This script is quite extensive. So first it checks if Objective-C is available. Then it loads all the classes from the local authentication. And then it intercepts the can evaluate policy error. And it will be forced to always return true. I think it was already the case, but just to be sure. And then also the evaluate policy implementation we intercept. So we create a specific reply block in this case. This is how it needed to be done. And then this implementation will be set to true and the error will be set to nil. So this is one specific way to do it. Of course, you can Google for examples, maybe ask CIPT. And then you might end with a script like this. And then instead of FRIDA trace, we can run FRIDA USB again, -L, and then the name of the script. So biometric bypass is my script called. And we can attach to the same process if the app is still running. So script loaded successfully. Then I can test if we can get rid of those errors. So first let's try the Swift implementation. Success, authentication successful. So set evaluate policy return to true. And also evaluate policy is also intercepted. So this proved the script works for the first implementation. And we can try the same for the second one. Success. So it's quite similar. So probably the source code is different if you will look into it. But eventually it was both using the local authentication API. So in that sense, we just needed one script to bypass both. And you can also find some documentation about how to fix those issues. So for example, this Ostalab website also has a nice list of issues and fixes for different languages. So how can you fix this in Swift, for example? This was an example of device and OS level features and specifically biometric authentication issues. So I hope you enjoyed it and see you in the next video.